Hey guys and girls, welcome back to another beautiful video here on our beautiful channel where today we're going to go through really quickly just templates. So we're going to introduce templates here, and templates are very important before we start with classes, right? Because the big thing with classes is that you can use something called a template class to not bind yourself to one specific type from the beginning. So to understand that, I'm going to show you. So what you usually use templates for are functions, okay? Functions and the variables inside them. So basically what you do, say that we create two functions here for a multiplication and addition and a subtraction. Let's keep it to that. So we had our functions, remember? It's going to return, we had one int, for example, add, and we had int number 1, int number 2, like this, and we went ahead and returned result, and we had a int result equal number 1 plus number 2, for example. This is an addition function, okay? Just adding two numbers together. Now we're bound to integers here. If we want a function that works for doubles, we're gonna have to straight up just copy this, and we can use function overloading like we talked about, the same name here, but make sure we have a different parameter list, and that would give us this. Basically, we have to add function and this works, but this is a little tedious if you're gonna have a bunch of different types going in here. You can have floats as well, you can have long ints and all kinds of stuff that you might want to do. So go ahead and use templates in that case if you have a function that you want to be a little more generic. Okay, it's a generic type. This is a specific type, right? It's an integer and it cannot be anything else. We can create a generic type here, which would at runtime, at the time of the call, decide what type all this is going to be. Okay, so what you do for that is you write template type name t. Okay, you can write anything here. You can write lel, whatever. That type name will be the replacement for this, the type name. So, but you usually write t as a standard. Okay, so t, you just straight up do this. So t tells the program basically that, okay, I don't want to know the type from the start. We'll decide the type when we actually use the function. So just chill out. Don't go ahead and do anything rash now. So t is going to reserve that type here, and of course you can only use one type here. Like if you start putting in a double here and a integer, that won't work. It's gonna take one, and it's gonna start complaining if you try that. You can have one at a time, so you can multiply or add two doubles or two integers or two floats, two of the same thing, and then it's gonna decide all the rest. Okay, so let's go ahead and call this add. Let's start with integers. 4. Okay, see, if I try to put in a double here, it's gonna start complaining here. Yeah, see, int double. So you don't want to do that. You want to make sure you have the same thing here. Okay, we have a template function, our first template function, 7, that worked. So say we want to do a addition on, whoops, like that, on doubles. It will decide that that's either a float value or a double. So as you can see, it automatically created the type here, decided the type here for us. This is a generic type, again, just to repeat. So yeah, there you go. And if we do the same thing here, we make a subtract function like that. What you need to remember is you need to do this every time you create a function above the function header, okay, or the function prototype. If you have your function down here, you know, like we did with the prototype, then you're going to have to copy that thing as well. Okay, copy this whole thing here as well, just like that. That's what you're gonna have to do. Okay, so remember that. Remember that. Otherwise, it will not know what this is. All right. So that does not seem correct. That seems more like it. Yeah. So that's the way you have to do it, sadly. And oh, whoops. I done goofed up. There we go. Okay. So yeah, there we go. Let's do the same thing for this. Let's just do this, and then we'll take this away. Do that. and we'll do that. So there we go, easy. Just so you learn all the small tricks and stuff. So number one, all we have to do is just take minus there, and this is going to give us a subtraction of, let's say, let's subtract 5 and 2. Okay, let's see what that gives us. It should give us 3. Yes, it did. And we could 2.0, 5.0, which is going to give us a double. Yeah, still 3 though, but let's do 0.3. There we go. Yeah, there we go. I double. So that's about it. Now I can show you one more thing with templates, is that you can actually have 2 different types. Or actually, you know what? I'll save that. We'll have that in another video, or we'll just go through too much at once. So these are template generic types. Go ahead and try them out, play with them a little bit. Just make sure you know why you're using them, and you'll be fine. So yeah, thanks for watching, and I'll see you in the next video. Bye-bye. Hey guys and girls, welcome back to another beautiful example video here on our beautiful channel. What we're going through today is just classes. We're going to start with classes today. This is going to be great, and it's going to open up doors for us to make all kinds of examples. So let's get started. I included string and vector just to give you an example of what is going on. A string and a vector is a class that someone else made. These are classes. So the thing is that when you create your class inside your main thing here, you're not going to have to include it. You can create it in here, or you can create it in a separate file. We'll talk about the separate file includes and stuff later. So let's get started here. Let me show you that a string is a class that someone else made. String str, for example, is a class, right? This is a user created class that someone made. Then there are standard types, right? Like an integer, a double, a float. Now we haven't talked about floats a lot, but floats are basically doubles with less accuracy. And you can write f afterwards. This just means that this isn't a double we're trying to put into float, because it's going to have to convert that and then put it in here. So we just write f directly, so it doesn't have to do that extra conversion. So that's a float. Then you have booleans, of course, false, for example, and such, and so on and so on. And of course we're forgetting char, which has to do with our string. So our string is a class that someone made. That's why it's green. These are standard types. Standard types can be used to build classes, for example, like string. So a string has a character array in it, right? Something like this. But and that you can, it's a dynamic array like we've been making. So that's exactly how that works, right? It's something that someone made and thought that, okay, if we have an array of chars, we can actually have a long line of characters to make a sentence, for example, and that's a string. And then you have vector, which is another type of class called a template class. Now we've talked about templates and how they work, and this is a template class. So at compile time, it will decide what type this vector should be. Okay, when this object is created, either at compile time or runtime, this object will be created, right? And then it will choose what type it should hold. So that's a template class, but it's still a class because inside here is a dynamic template array for any type that you can add and remove and stuff like that. So you can call this int vec, for example, and there you go, that works. So they're like Lego pieces. These are the basic Lego pieces that build up these user created bigger Lego pieces that you can still build with. So just think of it all as a big Lego box with all kinds of stuff in it. And we're gonna make our own Lego piece today called person. So this is a very simple class. It's good to start off with because it shows you basically what a class is. A class represents, let's say, real life objects to make it convenient for you to put them into programming form. If you make a game, you have a class character, weapon, item, map, whatever, game, all that stuff. Okay, and in any different scenario, you can just pull in things from the real world and make a class. And you're going to have to use this a lot. This is the base for object-oriented programming. So let's get started here. Let's say class person. Now what I do is when I create a class, the first letter is always capital. I know these aren't. Because they're meant to be types, and you don't want a type to have a first letter capital. So, but your own classes, you should have a capital letter here. Private, public. So I'm going to explain all this. Protected. Protected is something you can ignore for a long time until we get into inheritance. So that's a whole different topic. But so this is just ignore right now. Public and private, well, they're just what they are. Private, the private section, make sure that all the stuff that is written here, created in here, will not be accessible outside of the class. String has a bunch of private things, like the actual array that holds the characters is private. You can't actually go and directly access it and do stuff. So you're going to have to go through different measures to get to it. Public is basically everything that you can access from outside the class bounds. For example, all of these functions here are in the public section, and the actual function that creates it is also in the public section. So we're going to talk about all this, and you'll understand as we go along. But let's get started here. String. All the inside, the guts, are going to be in our private section. Things we don't want the user to access directly. So the name. And you're asking why? Well, of course you want the name to be accessed from outside. Well, it will be, but through a function. So we'll make it much clearer. And that's more for programming, clean programming reasons than for anything else. You could have these in public and access them directly, but it doesn't make sense. It doesn't make a good, programming habit. So a person might have a name, a person might have a date of birth, and person has an age. Not might, they do. So they do have these three things. You can add a lot of different things here, job, all that stuff. But we'll just stick with these three right now. So we're making a person from the real world. We're putting them into the computer somehow, a type here. So what you have to have in your program is a constructor, or in your class, excuse me, and a destructor. And we'll see exactly what these do as we go along. The constructor is only called once, and it's called at the creation of this. Here, actually, if you write it like this, the constructor is being called, the default constructor. There are no parameters. Remember, when we call a function, you can send in parameters. Well, this is the function that actually creates the object. So anytime you're creating it, you're calling the constructor. Okay, and there are different constructors that you can have. And they all are written this way, with the class name and then the function header, or the parameter list, excuse me, and the function body. Now, the destructor is written in the same way, but it has this thing in here, and you only have one destructor. Remember that. Only have one destructor. You don't have several destructors, but you have several constructors. And a constructor is, they're defined by their parameter list. So a constructor has the same name always, but the parameter lists can differ, and that means you can have several different ones. So this is called a default constructor, since it doesn't have any parameters. All this does is actually just initiate your variables to something to have a start value, right? So xx, xx, xx. You won't actually use this when creating a person. Okay, you could create a person like this. Just here, we can actually create a person now. Person P1 and person P2. Okay, so this gives us another important topic to talk about. P1 and P2 are different persons. They have different versions of these, different copies of these. Okay, so P1 will have its own name, date of birth, and age. P2 will have its own name, date of birth, and age. They have the same exact things. This is like a template. This is like a big blueprint for a person. And these are following that and actually going through and creating these for themselves. So we'll see what happens now. This default constructor will be called in this case. We don't want that. We want to create a person as soon as the person is created. I mean, give the optional constructor. This, we want to give a person some logical values, right? We want to create an actual person. So what we can do is string name, string date of birth, and then int age. Now you're saying, these are the same values or same names, and how are we going to change these actual values, not the local values in here, because you're giving them the same name as the member variables. We can write that as member variables. This is what they're called. Now there is a way in every class. Okay, this is something you should know from now. I'd say there is a pointer called this, something that you don't have to define. It's always there when you're working in the class, brackets here, okay, and you're working in the functions and things like that, and you want to access the actual member variables and the member functions that we'll have down here, then you can use this. And in the case of local variables having the same name as the member variables, you can differ them by using this. So this name, this date of birth, and this age equals name, date of birth, and age. Okay, so this name and this name, very different things. This is the local variable in the function, this is the member variable. And we're differing them because this name accesses the actual one, and it will get the value of the local variable name. So this is really good to know. I know it's a little confusing, but try to understand it, and you'll be fine. So what we can do is we can say person created, okay, end line, and here we go, destructor called for, let's say, this name. Now you don't have to use this everywhere. I do. I like to do it just because it tells me that I'm actually accessing this, but you don't have to. The only really time you need to use it if you have a local variable with the same name. So otherwise you don't have to do this. It will know that you're trying to access the class's own member variables. But I still do it just to make sure it looks good. So there we go. The destructor is always called at return 0 at the end of the program. Now I don't have pause here because if we use that, I'm gonna use another way to keep it paused, just so we can see the destructor being called. Otherwise you don't see it, it just happens and it passes and closes the program. But there we go, this is the difference. So now we actually want to use this constructor to give them some logical values, not just none and stuff like that. So the way you differ constructors is by the parameter list, like I said. And you cannot choose to just input one of these or two of these. You have to input all of these when you're calling it. Otherwise they will say, there is no constructor with just one variable in here, parameter. So you have to do that. Either none or 3. Or if you want 2, you can create another constructor with just 2. And they will be different because they have a different parameter list. So let's say we create Bob with the, date of birth, 90, let's say 1202, and the age of, excuse me with the age here because I'm not gonna actually follow the real life clock here. I don't really care that much, to be honest. So we just want to see so it works. And then we have John, another person, P2, can also hold a name, age, and a date of birth. So he's a few days older, but he is somehow 230 years old. So John is a old person, and this is a young person. So there we go. There we go. That way we have a bunch of stuff using this constructor. And a member function basically are just functions that can only be called from something that is of the type person. So if I create a function here, void print out, okay, and that's basically just gonna see out everything together. Name, this, name, just to be clear, DOB, this, date of birth, age, this, age, and line. So this is going to print out everything in a line for our person. So we're just going to make sure we print that out down here. P1 dot print out, P2 dot print out. So they're different variables, and we'll see what happens now. We'll see. This will be interesting. Oh, whoops. Yeah, this is the reason I had system pause. Well, what you do to keep it paused is you go into debug and you say start without debugging, and it will keep it open. And then you can see the destructor being called. We didn't call the destructor ourselves. Okay? The program does it. The compiler or the program does it for itself. as it wants to. All of these destructors are being called for everything, but we just specified for person, the person class, that it should print something when the destructor is called, and that it did. So for John and Bob, two different objects of the class person, of the type person here. And name Bob, see, they're very different. Person created, person created. So everything is seen here working. And I hope you learned something from this. I've been rambling on too much. I'm sorry, but I just want to make sure you're really clear on what's going on here. So yeah, thanks for watching, and I hope you learned something again. Keep working hard, get real good, and I'll see you in the next video. Alright, bye-bye. Hey guys and girls, welcome back to another example video on our beautiful channel. Today we're just going to be talking about some more class action, and what's going to happen is we're going to make a dice class. Of course we're getting back to dice because that's awesome, and we're going to just use that dice and throw it, and we'll make multiple dice, and those dice will themselves return a value to us. That value that they return will be printed out eventually. So to do that, to make a dice, we need to include ctime, of course, because we want random, right? So we'll initiate our srand. Okay, just like that. There's another way to do this. Your teacher might say, we haven't talked about casting yet, but it's pretty simple. I think this is how you cast to... Yes, I think this is how you actually cast for this time thingy. So we could do this as well. You could just write null, do whatever you want. It should be fine. So let's see here. Let's just see if that crashes. Now we're good. We good. Okay. So let's make a class here. Like I said, we won't be talking about classes in different files yet. We'll come to that later. Now the reason to have them in different files is because classes can be really long, and if you define all your functions there and have a bunch of accessors and modifiers, it'll be a pretty big list. And to go through here where your main is, if all your classes are where your main is in the same file, you'll have a big file full of stuff. So the general idea is to make every class that you make in a separate file. So you have a file per class, and you're making objects in those files. And then you can use them to create actual objects in main, and then you'll have to include them. But there we go. Okay, so we initialize that. So we'll call it dice, like that. I did check up the grammar for this, since I've always had a problem with that. Dice can be singular and plural. It depends, and you can also say one die, one dice, one die. I don't know, man. I'm confused. So I'll just keep saying dice. That's fine. Then we'll have int max value, okay, because we'll go from 0 to a max value, and I think that's all the dice needs. In one max value in private. Now you don't need the protected part. See, I'm ignoring it because the protected part, the computer won't even care about it unless you actually define it here, or specify it there. So don't mind, just ignore that. We won't be talking about that for a little while. But anywho, let's go in here public. Let's do our constructor. Let's say dice. And let's make a destructor, dice. Now, we don't want to make a dice with 0 sides, right? Or 0 max value. So we'll force the user to enter something. Now, the thing is, you must have a default constructor in every class. You must. Okay, you must. So we'll default max value to 6 if the user doesn't input anything. This makes it so that the constructor is both a default constructor and a optional constructor. See, because if you don't input anything, it'll be a default constructor, but it will still initialize it to 6, sorry. Or if you do put something in, it will be an optional constructor, and you will be able to customize that value. So this max value equals max value. Now remember the difference between this max value and this local max value here. This max value is the actual member here. So we have that, and we don't need to do anything in destructor. Remember, we printed something in the last video, but you don't need to. I mean, it takes care of itself. It destroys the whole dice object for you. And then we'll have a member function called, it'll return the value, throw. Whoops, no, don't use throw. Dice, or toss. Let's call it toss. And there we go, toss. And how many times do you want to toss it? We could have that as well. Okay, we could have that as well. Times. Okay, just like that. We could do that if we wanted to. So you can toss it several times. And let's say that it returns times rand rand no equals 0, and we need a for loop, right? You need to throw it several times. So times, and then we'll say result plus equals to rand max value plus 1. Okay, there we go. So it'll just add that, and then it will return result. There we go. Perfect. So that's dice class, ladies and gentlemen. That's all you need, and you have a toss thingy here. So what you do in main then after that is you can create a dice d1, dice d2, and a dice d3. Now all of these are using the default constructor, okay? And they will be 6, max value 6, so 1 to 6, right? But if you want a dice that has a higher value, you'll have to say that. So I want a 14, d14, right? And I want a d20. There we go. And now we can see out d1.toss. Okay, now we'll just toss all of these, and we'll say times equals 1 as a default value. Okay, so if we don't want to give anything in here, it will just toss it once. That's good to know. So we'll toss this, just like that. And then let's see, 5, 10, 16, 6, 1, 9. So it seems to be working. Let's see if we can max value. Okay, 1, 13, 9, almost a max value. And 2, 5, 10. One more time. This is fun. Oh, this is fun. Woo! 4, 10, 11. Okay, we're good. We're good. Yeah. So that's basically a very simple dice class. We made a dice. We made sure it could be tossed. We made sure it was initiated or initialized to a side. So we didn't have a zero-sided die, a zero-value die. And yeah, you can toss it several times. So let's toss it. Toss everything 5 times. Let's see if that works. So 17, 39, 49. It seems to be working. So that gave us a big different values here as well. That's good to know. So there you go. That's a very simple program with the dice. Do not put 0 in there. Okay. So yeah, thanks for watching. Take care, and I'll see you in the next video. Bye-bye. Hey guys and girls, welcome back to another beautiful video on our beautiful channel. We're going through another example now. We're going to make a person class, and we're going to make an array of 10 people, and we're going to print those out, and we're going to change them around and see how stuff works. Okay, so let's just go straight ahead into that. Include string, because we're going to need to make a name variable and a date of birth variable. So let's make a class person, and let us just make a private section and a public section. You don't need a protected section like I said in the last video, because it just ignores it, and that has to do with inheritance, so we don't need to care about that now. So the public is going to have a constructor and the destructor for person, and we're going to have a function called that returns a string to string that returns the whole person class. You can have it as const just to get good habits in. Anything that doesn't change let me see, yeah, there we go, that doesn't change the member variables can be a const. Any member function that doesn't change member variables can be constants, and they're good. That's better, that's more efficient. So do that. So we'll have string name, string dob. Okay, let's just call it dob. You know what that is. Date of birth, name, date of birth, just to make it a little short. So what you can do, what is beautiful, is if you return a string, you can chain strings together. Okay, you can chain them together. You can't chain different things like integer strings together like that and return them as a string. You'll have to two-string that and make it, or use a string stream or something like that. But In our case here, we don't have anything else, we just have strings, so we can easily just string them together. So name, and that includes literals like this. These are string literals, which aren't any variable or anything, just straight up strings. So, oh, plus. And the reason we can do that is because the plus operator is overloaded within the string class. So it knows what to do with the plus. So name, and then date of birth, plus, oh, this. It doesn't really matter in this case, but this is a good habit to have. I like using this. Sometimes I forget, forgive me, but in this case I want to do that. So what else we can do is name, empty, is make this into a default constructor as well as a optional constructor. So string dob equals like that. Now it has default values. So if you don't input anything in here, you're going to get the default values, which makes it a default constructor. And if you input something, it will change name and dob into that, whatever's specified by the programmer. So this name, that's why we do this. That's why we do this. Name. Whoops. Okay, just like that. So in case something else is inputted in here, not left empty, you will get whatever you inputted into here. So there we go. We have our person class ready. It's ready for action. And what we're going to do is we're going to make a person array. Now, how do we do that? Well, it's the exact same thing as anything else. You can make an array of strings, of integers, and your own classes. So persons, let's make a constant as well here. Constant cap. Let's make 10 people. Now remember, this is a static array. This is a array that will not change. It will always keep one size. So we want to make sure the cap is always the same. The program compiler wants to make sure that cap's always the same. So we need to give it a constant integer. In dynamic arrays, we're working with regular integers. Here, because they can change, here we're talking about the constant that we're sure will never change. So we have cap there. Perfect. And let's see. Let's just print all this out and see what we get. We'll get all the default values. Persons dot, remember toString because we made that function just for this reason. So it will print this out for every person. Bam, 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 bam. Perfect. Perfect. Now you're asking, how do you change this? Now this is a little complicated. Now things you cannot see here do actually exist. There is something here that isn't written out that you can change if you would like, and that's called a copy constructor. Okay, this is a regular constructor, and there is a copy constructor. Now a copy constructor is created, and there is an assignment operator as well, and those two things are a bit different. So actually what I'm trying to say here is the assignment operator. That's what I'm trying to explain, because that's what we're going to be using. So there is one for this class, default. Okay, now the reason it's default is because most of the time you don't have to specify it yourself. C++ takes care of it. But if you have pointers in here, string pointer something, and then using that default one, it will do something with this that you do not want. Okay, it will do stuff with this that you don't want. It will take care of it, but it will not take care of it in the correct way. So when you're using pointers in your classes and dynamic memory, you have to make your own assignment operator and your overloaded assignment operator, and your own copy constructor. You want to make sure you do that. We'll get along to that later, but as you know, I always say things in the beginning just so you have these ideas in your head. Those two things are here that we can't see, and we'll have to specify them if we're using pointers. But in our case, we're not, so we don't have to care. That means that we can use the assignment operator. So persons at position 0. Remember, this is a static array. There is already a person in here, but we want to change that person's values. So we can do this. Create a temporary person and name him Bob. Give him date of birth. 1990, or whoops, 90. 0512, for example. Maybe that's the same date I used in the last video. I'm not sure. Anywho, we'll make a few of these changes here. They can have the same date of birth. I don't care. John Mac. So we added 3 here. We changed the values of these 3 in the top to what we wanted. Now this is inefficient, right? This is not the most efficient way to do this. We'll get to the most efficient way using a dynamic array. But in theory, actually, you could do that by yourself right now if you've been following. You could create a dynamic array of persons and make sure it's working, and use the new operator instead of copying like this. So this is the assignment operator that you can overload, and it will be important to know later. The copy constructor is used when you create something out of something else of the same type. Okay, so if we said person 1, persons 0, if we did this, we're using the copy constructor. Okay, we're creating person 1, copying from another person type. Okay, person object. This calls for a constructor, but a different type of constructor called a copy constructor. And that makes it so that we can copy over values from this into the new one that is being created. So that's the difference between the assignment operator, which you can use at any time, and the copy constructor that is only used at the time of creation. So there you go. There you go. Now you could change all these values if you wanted to. We didn't use the menu system actually because it's a simpler way to just do this, I think, and just to show you how this works. And remember these the terms here, and we'll be fine. So go ahead, play around with this, see what you can do. Thanks for watching as always. I really appreciate it, and keep learning, stay strong, and I'll see you in the next video. Bye-bye. Hey guys and girls, welcome back to this beautiful channel on this beautiful day to another beautiful example where you're going to learn more about classes. So this is just another class example. I'm just going to go ahead and make a nice class here. For example, a car, and then we're going to add another class into that class. Okay, so this is kind of a thing you can do. All right, this is important. This is good to know. Now, we're not going to go into detail really about some software engineering terms here, but there are ways you can do this. Now, let me show you something. If you have a class car, okay, we know that cars have wheels and cars have windows and cars have stuff, right? And those can be classes too. So you can have a class wheel. Okay, let me just copy paste this to be lazy. Okay, so what can wheel have? Well, wheel can have inches, like a size, right? Size in inches, for example, and then like the depth and stuff like that. And a car can have a wheel, right? Wheel left front, for example. Okay, so what's the thing here? Well, this wheel can be created somewhere else besides in car. Like we can create a wheel 1 here. Okay, but do we need to? That's the question. Do we need to? Does wheel ever have to be created outside of car? Now, that's something that you have to decide. Alright, now in many cases it could be, but in your specific program maybe it doesn't have to be. Maybe it is wheel can only exist within car. Then what you can do then is you can straight up just put the class wheel inside of the class car. Okay, you create it in here. Now this takes a lot of space, right? Okay, this might take a lot of space and it might be completely unnecessary to do, but you could do this. In our case we won't, because like I said, it takes space and it becomes a lot of like very unreadable. So we'll just keep it like this. Now that is good to know, because that is, if you're gonna study software engineering and software design and UML diagrams and stuff like that, you're gonna talk about that. You're gonna talk about when what is good and how it can benefit you to do these things in different ways. So just keep that in mind. Anywho, for this example we don't have to. It doesn't really matter anyway. So wheel has a constructor. Wheel has a constructor, and wheel has a destructor, and wheel has a, or car has a destructor and a constructor as well, of course. And there we go. And then wheel is going to have a int get inches const. Okay, and we're going to just say return inches. Okay, so we can get that in here. Now wheel has a private variable inches. And just because we create a wheel object in sidecar doesn't mean we can access wheel's private members here. Okay, so we still need to get inches through a accessor. These are called accessors, just like I said. And if you're going to modify any of these through a function, we're going to say setters, or no, sorry, modifiers. Modifiers. Okay, now we can just make one just to show you how that works. So what you can do in a modifier is you can say set inches. Okay, now this isn't the best name. Inches isn't the best name. You'd have like size or diameter or something like that. But I just said inches here just to be kind of dumb. That's not a good idea. So make sure you do, you know, come up with good names here. Inches equals inches. So int inches. This is not a const because we're changing a member variable. Then you can't have the function as a constant. So that is very important. That's something you need to know. Now here, just remember the optimization things, that we can return it as a constant reference because we are returning a member variable, and to save some overhead we could do this, and so it doesn't have to copy it. But again, we don't have to, but we can do this. We can do this in this case. Now this is how I do all my accessors and modifiers. If you watch my game development videos, there I'm trying to keep it very optimized, so then I use this. But anyhow, let's do this. Now we'll have four wheels. We'll have four wheels. Left front, right front, left front, right front, left rear, right rear. Now this is kind of confusing, but okay. We'll keep it at that. Now we have a bunch of wheels. Now you can make more classes. You can make a class windshield. You can make a class door. You can do these things and you can add them in here. Now that is important in game development as well. You could do things like this. But in our case, in this case, it doesn't really matter. So inches equals 0. So we'll just initialize that. Now when you make a wheel here, you can't really initialize it directly. So you use the default constructor, and we can make a default. Actually, no. This is, or actually, yes. Do you know what? Yes. Let's say int wheel or int inches equals. Let's give it a default value. Let's say 20 inches. Okay, and then this inches equals inches to make this both a default constructor and an optional constructor. So there we go. There we go. There we go. Now we're good. Okay, and yeah, that's perfect. Now we're going to, in here, get, let's see, get wheel, and then you're going to be able to give in a number, index, okay. And depending on that number, we'll return a wheel. And that wheel will print out its stuff. So here, let's make a few different wheels. Now this car is going to be really strange. This car is going to be really strange. Wheel, excuse me, wheel left front equals wheel, let's say this is 22 inches. Okay. Now we're gonna make a initialize our wheels here. Left, right, rear. Whoops. Left, rear. Wait. RF. Left, rear. Ugh. Left, rear, right, rear. Okay. Is that correct? I think that's correct. Okay. So we have 22 inches. We have a 24-inch wheel. And we have a 26-inch wheel and a 28-inch wheel. So this car is straight up crooked, okay? This car is like gangster lean. Okay, so we have that there. Now, depending on which one we take, now let's say a switch case. It was a long time ago. We use the switch case. Case 1, case 2, case 3, case before, and this saves us some headache because we have a default here, which will help us in life and difficulties. So there we go, and here we go, and here we go, and here we go, and here we go, and then we'll say int, or we'll say actually, let's make a wheel pointer. This is another way to use a wheel pointer. Okay, so we're just going to, depending on which one, dr equals this wheel left front, if we give it 1. Remember the address to it. Okay. You should know what a pointer does now. Left rear, no. Right front. Whoops. Whoops. No, that's correct. I'm smart. Okay. Left front. Left front. Right front. Left rear. And then right rear. Okay, so our pointer is going to point to the actual wheel depending on which one we which number we take. So if default, we'll just say no wheel above wheel 4. Okay. Brah. Long time ago I wrote brah. So here we go. Okay, so it's gonna point to that, and since we have to return a wheel object here, what we're going to do is we're going to return WPTR. Just like that. Oh, whoops, dereferenced that. So it's going to return the a copy of the wheel that was pointing to. So now the question is to optimize this. Do you want to send, because wheel is a big object. Now I would like to send a const reference here to, whoops, we could do that. Yeah, you can send a const reference to a dereferenced pointer, and that should be good. So in this case we have a car, and car is going to only use wheel here. So we'll create a car. Crooked car. And it has its wheels now. And then what we're going to do is we're going to get a wheel and print it out. Crooked car dot get wheel. Let's get the first wheel dot get inches. This is a long function call. Let's get all of the wheels and print them out. So 2, 3, 4. Let's print these out. Let's see if this program even works. 22, 24, 26, 28. Beautiful, beautiful, beautiful. Okay, now what we're going to do is we're going to change the inches of the first wheel and the last wheel. So the first wheel, set inches to 30. Woohoo! This is going to go crazy. Okay. Excuse me? Excuse me? Oh, it's a constant reference. Ah, excuse me here. Since we're going to, what we could do is do this. This is kind of unsafe, but you can do it. Just in this case. Actually, what you want is you want 2 functions here. So don't do as I do, do as I say. Make 2 versions. Actually, do as I do, okay? Do as I do. Do as I do. This is better. Set wheel at an index. So we know what's going on. Yeah, do as I do. Do as I do. So set inches. Set wheel. Okay. And this is a constant wheel reference, and this is this. Okay. So this is better. Okay, and then the, oh, whoops, the last one. 4 to 30, 38. So it's even more crooked now. And then we're going to print them out again. Just like that. So then we have a 30, 24, 26, 38. So yeah, we can change them and we can print them out. Now, yeah, I apologize for all this hoopla here, but it doesn't really look that nice. But it's a way to show you how classes can be put into classes and how you can return them as just regular objects and change them around and use their functions, stuff like that, in chains here. So yeah, I hope that helped. I hope you learned something, and I hope you have a great day. Take care, and I'll see you in the next video. Bye bye. Hey guys and girls, welcome back to another example video on our beautiful channel on this beautiful day. Even though it's raining outside here and it's cold, we're going to be programming, so it's all good. No one said we're gonna go out for a jog, right? So let's do this. So what we're gonna do today, well, we're gonna keep working with classes, of course. Now my idea here is that we're gonna make a class called dice, just like before. Alright, we'll make sure dice can throw itself, okay, and return an integer for the value that was rolled. And then what we'll do is we'll have a semi-dynamic array of pointers, and we'll fill it up. Or we'll let the user decide up to 10 how many he or she wants, and then we'll throw. Alright, so yeah, let's just go ahead and do that. Let's just go ahead and do that. So what we're gonna need is an int capacity. Let's say you can have max 10 dice, and then int number of dice, alright, from the beginning. Then we'll have a while loop for our menu system. Okay, then we'll have an int choice. Alright, choice larger than 0. As soon as it's 0, we will quit. So what do we want to do then? Well, we want to, whoops, dice, delete whatever array we have here. So we're gonna have a dice array. So what we need is a dice class. Dice, alright, private, public, and our dice is of course gonna have an integer max value. Okay, and then we're going to give it a constructor, and we're going to say that in the constructor equals 6. So you can have 8 or 4, I think, is the least smallest die you can have, I think. Well, let's say that. Anyhow, excuse me. Whoops. Sometimes I'm bad. Alright, dice. Just like that. And then we'll have a int or toss. And then we'll just do it once in this one. Toss. Return rand max. This max value. Just because this equals max value. So there we go. That's our dice class finished. That is it finished. Now all we have to do, we have to fix the random. So include ctime. Alright, and we're gonna just go ahead and srand time static cast unsigned 0. So there we go. Now I used to write null in here, but this is a better way to do it. I heard it's more efficient at least. So go ahead and do this instead. Plus it looks more pro. So just do that. And let's see. That's it finished. Well, let's do a dice dice array. Let's make it a pointer just to practice some more on pointer so we don't forget, right? So new dice pointer. Let's see. Dice pointer cap. So we have max 10. We can have max 10 of these, and we'll make sure that we can't add any more as the number of dice increases to 10. That we can't add anymore. So there we go. Delete position I, and then remember to delete the whole thing. Dice array. If you don't remember how to do pointer arrays, oh, they changed this to blue. Interesting. If you don't remember how to do pointer arrays, go ahead and watch my example 40 something, somewhere around there. There's some pointer examples there, and I go through them in very great detail, so you won't have a problem. But anyhow, let's say this is the delete final. Alright, this is the final delete thing. And Okay, so let's just go ahead and make our menu here. Alright, so void menu. I'll do it in a function here, and we'll just take in the choice as a reference here. Okay, so switch choice, just like that. And case 1, case 2, break. So what are we gonna have? Well, we're gonna have print out all the die, toss the dies and give us the total values, and toss the dice, and we'll see what else we can do here, but we'll just start with those two. The important thing here is that we make sure that we have the class and we can use it in a pointer array. So we learn about that. That's the important thing here. Raw input bra and that line, and then we have the number 1 to print all the die. And what we're gonna have to do here is we're gonna have to send in the dice array. So we're gonna have to send in dice pointer dice array. Okay, so we have that there, and we are gonna have a constant on that, I think, just to make sure we don't change it. And then we're going to, oh yeah, we need to add as well, and we need to do that. So integer constant cap constant. We're not gonna expand, but this can't be const because we're gonna increase int number of dice. We're gonna increase number of dice through here, so we can't do that. Now, okay, now the reason I didn't create a dynamic array yet with a class is because I'm waiting for that. It's a little different, so I'm just gonna do a little more of these class examples, and then we're gonna go ahead and do those fully fledged template class dynamic arrays. But for now, we'll just stick to this. Number of dice. Okay, just like that. And we don't want the excuse me. Oh, because it's constant. Excuse me. Excuse me. Oh, I am so dumb. I am so dumb. Never mind that. Never mind that. Okay. Never mind that. What we need is an int get max value, and we'll just make that constant, and we can make this constant as well. Constant, and we will say get max value int const int reference return. This is just again to make it as optimized as possible. Max value, because we're returning our member variable, we can do it as a reference and put constant on it so we don't actually change it, and a constant here because we're not going to change it. So this is like the most efficient way probably to write this. And get max value. There we go. Then you don't have to do this. Bam. Okay, so you get the max value and the actual index where it's at, and then max value. That's what we want here. So get max value for all dice, and then we have 2 toss all dice and get the total. So we're going to toss them all, and we're going to get a total value from them. Now to do this, we're going to have to make an int total value. Okay, and we're going to have to say that total value in a for loop, of course. In a for loop, dice dice array here, total dice array at position I, toss. Okay, so that's just going to, whoops, what was my name? Total val. So total val, bam, it's gonna get the result, fill that out, and then we're going to say total value of all dice, and then we're gonna say total val, just like that. Now I said I was gonna start using /n in a previous video because it's a little more efficient, but I'm still using end line somewhere here and there, so excuse me about that, but change your habit if you can. It's a little too late for me, guys. Oh god. No, but you can do that. You'll be fine. You'll be fine. It's not that, I guess it's not that much more efficient anyway, but it's yeah, it's a little more pro. So we got that down. We got that down. 0 is quit. So as soon as we do 0, it's going to exit. Now what we need to do is we need to, actually this could be 2, this could be 3, and then we'll have case 1, which is add dice. Okay, just like that. And we'll say that dice array at position with dice plus plus, whoops, new dice, and we'll get a number for that in there. But we need a if statement, if number of dice equal less than cap. Okay, if it's less than cap, we'll do it. If it's equal to cap, you cannot. You cannot. That is not good. Okay, because then it's going to be equal to, and that will be the final one. So we have this if statement here, whoops, and we have this. So now all we need is an input from the user. Cout add a dice. Okay, input max value for dice, and then cin int max val 0 val. There we go, and then we'll say max val in there. And now every time menu runs, it will create these two, which is kind of meh. I mean, but it has to be done. So there we go. There we go. Okay. Okay. I think this should be fine. And then in the while thingy, we'll start with, we have to actually do this. Choice. Of course. Choice. Okay. Menu, and then we'll say, align that, and then we'll say, we'll just copy this. 1 equals add dice, 2 show dice, 3 toss all dice, and then choice. Okay, let's do one more /n for good measure, and then we have our choice thingy. Now we're gonna have to do menu first once up here, menu, or main menu, and then choice dice array cap number of. Okay, there we go. That's our menu function, and we'll just do that in there. Now this is going to crash so hard on me, but I don't know why. We got some issues here. Okay, we got some constant thingy problem. So we're just gonna do that because a constant pointer is another thing. I think that was the only problem. Yeah. Okay. So let's just see show dice. It does not crash. Toss all die does not crash. Add a die. Let's add it to 12, and then show die 12. Yes. Toss die. Yes. We're getting different values. Yes. Yes. Add a die. We'll do a 20, and then we'll show it 12, 20. Toss all die. Oh, we're getting some big numbers here, guys. Oh, we're gonna win. Oh, whoa. Hell yes. So that worked. Now that quit as well, and we won't get a excuse me, give me 1 second here. We should not get any memory leaks. We should not get it. These are some old examples that I made. Some template stuff. Let me find that thingy. Where is main? Where is my main? Where is my main function? Okay, I have been really bad, guys and girls, because I haven't used that debug assertion thingy, the one that shows memory leaks, and I'm trying to find it where I used it last, but I don't think I'm gonna find it, sadly. I do not think I'm gonna find it, main. I don't think I used it in a while. Oh, it should be. No? Just a second here. There should be one. Right here. Okay, never mind. Never mind. Well, that was it then. Use that thingy if you find it somewhere. And it should be fine. But it shouldn't be any memory leaks here since we deleted everything. Right here. So that's it. That's a simple dice thrower program with a limited pointer array and a class and a function. So that's a good big meaty example for you. Enjoy, take care, thanks for watching. I hope you learned something. Sorry about the ramble here at the end trying to find that thing, which I didn't find, but whatever. I'll use it in the next video. But thanks again, take care, I'll see you in the next one. Bye bye. Hey guys and girls, welcome back to this beautiful channel, and where we're gonna make another beautiful example video. And what we're gonna talk about today is more class and class stuff. And remember a few videos back I made a car class with 4 wheels in it, right? Now today I was thinking we'll make a truck class with maybe an array of wheels instead, and an array for, or actually wheels are not going to be in an array. They're easier to access if they're not in an array, but the inventory for the truck will be an array. So we could do that. We could create that. So we'll have a class truck. Okay, truck, and then we'll have a class, let's say item. Okay, let's say private, public, lazy, 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 lazy. Okay. Let's call it size this time, not inches like I did last time. And item is going to be a string, so make sure you include string. You can take away seed time. String. So string description. All it's gonna have is a description, just to make it easy. Item, you can add whatever you want in here. So this, let's say description. Alright, so we're gonna force the user to make an item with the description here, and we'll just say none, just as a default constructor thingy. Because remember, we have to have a default constructor, we can't just not have that. So we're gonna have to do that. So there we go, item, and then let's say string get desk. We'll just do that, and then const string reference const, and then we'll say return this description, just like that. Just make it optimized. So that is our item class, just very simple, very, very simple. We'll have wheel, and we'll have wheel, and you should virtual, let's see if that actually does it. No, I think you have to do it in never mind. Don't think about that. Just testing stuff out, you know. So const int reference get size, const turn this size, and every time we make a wheel, of course, we want to make sure we get a size in here. Make a, what are they, 24 inches maybe, truck wheels, I don't know. Now we're talking about semi here, so what kind of a semi, whatever truck you want, it's up to you. You know, I give you that choice, okay? I give you that choice. Yes, yes. Wheel, no, size equals size, bam. So easy, easy. Now we can make a bunch of wheels. Now a truck is going to have 6 wheels. Let's say it's a 6-wheeler, and it's gonna have an inventory. So, excuse me, that inventory is gonna be an array of items. Okay. So, or let's maybe not a semi. Maybe we have a pickup truck. Make it a little easier for us. So wheel, left. Wait, wheel, left front. Wheel, wheel, left front, right front, wheel, left rear, wheel, right rear. Okay, this is always tough. This is such a tough thingy. And then we'll have a, oh whoops, item, pointer, yeah, we can have a pointer array. Inventory. Okay. Okay. Let's have a pointer array. Always like working with pointers. I really do. But then we need a cap as well. Whoops. An int number of items. Now these two, remember this cannot be initialized here. So we're going to have to do it in our constructor. So constructor is going to be quite big here. But it's worth it. Truck. And now we're going to use the destructor as well, because we have something dynamic in here that we're going to have to delete and such. And then we'll do the rest later here. So cap. Whoops, this. Cap. Let's say it can hold 20 items. This number of items starts with 0, and then this inventory equals new item pointer cap. Just like that. Easy, right? Easy, easy. Now I don't initialize my stuff here because I'm using number of items only. Like I said in my previous videos, I like to initialize, but to make the video a little quicker, I'm using this this other method that a lot of people use as well. So it's a little quicker. And it doesn't rely on cap, but it relies on number of items. If you've done both, I'm pretty sure you'll understand the difference and why they're different. But yeah, go watch the pointer videos if you haven't yet, because they're pretty important. I think it's about example, I don't know, 30 to 40, somewhere around there. Anywho, we have our inventory ready, and we need to initialize our wheels as well. You know, what we could do is we could make wheels into pointers, and we can just allocate that memory dynamically instead, so we don't have to do all that copy stuff. So we should do that. Wheel, whoops, wheel lf equal new wheel. Let's say they're 24 inches. Okay, let's just say all of these are 24 inches. Okay, wheel left front. Ugh, I hate this. Right front, left rear, right rear. Okay, and I'm just gonna be lazy, and I'm gonna make sure we delete these directly in the destructor. This is what the destructor is for. Okay, so these things, it cannot take care of itself. Anything dynamically allocated by the programmer, it does not take care of. Okay, this takes care of its own static variables. Like, it will delete the actual pointers, but not what the pointers are pointing to. Okay, so because the pointers are pointing to something in the heap, something that is dynamic, and you know, the actual pointer will be removed here if we don't specify this. But this specifies that before you delete the pointers, delete what the pointers are pointing to, the actual wheel there in the heap. So remove that first, and then at the end it will remove all the actual pointers from the system. So yeah, there you go. And the same thing with this, the inventory. We don't have to delete anything static. I think you should know that by now. Just everything that is dynamic using pointers. So let's go ahead and delete this number of items. Remember, you only have to delete anything that has been assigned. So all the rest of these pointers, that's why we're not going through cap, because the pointers aren't pointing to anything. We don't have to delete that. We just have to delete everything that has been allocated. So number of items, as we add them, something will be allocated, we'll have to delete that. So delete this inventory position I, and then we delete all of the pointers as well. Inventory. There we go. There we go. Now just to keep up appearances, we'll do that, and we'll do this just like that. Okay, we're fine. So now we have a bunch of wheels, we have an inventory ready for items, and we have them deleted here. So we have the wheels. We can make sure, or we can be sure that the wheels are created, because as soon as the truck is created, we have specified that the wheels are created here. So that means we can make functions that return wheels and stuff like that. So wheel const wheel reference get wheel left front. We can make a bunch of these, or we can make one. We can make a bunch of these actually. Okay. This wheel left front. Whoops, my bad. Okay, just like that. And we will do this. Whoops. Wheel left front, right front, left rear, right rear. Okay, and this will make sure we don't actually change anything for it. So we have that, and then we want to print out inventory. So void print inven. Now we know that everything in the inventory is a string, so we can just straight up print that in with cout. So for this number of items, cout I, just index, and then we get the inventory position I, because this is a string, we'll just directly do that. Okay. Wait. Oh, it's an item inventory. Okay. Never mind. We have to get description. Sorry about that. Forgot that. There we go. It's an item pointer item array, and each item is has a string in it that has a description. That's how it was. Never mind. I'm sorry about that. Just to make sure you understand that here. There we go. So now we can print. We can get every wheel. Alright, we can get the wheels and print them out. And we have an inventory. So we have the inventory where we should be able to add an item to the inventory. We'll do that in truck. Actually, what you'd want is you want another class called inventory, which takes care of all that, and you just have that one thing in truck. But that inventory class, guess what? That would be our dynamic array container class, and we haven't made those yet, so we'll wait with that for a little while. But yeah, we'll just make it something here. Add item if this number less than this cap. Let's add. So this inventory. Then we want the user to actually get a description. So sin.ignore. Okay, because if we use sin before that, we'll just remove that new line. So get line sin, and then we need a string description. Okay, desk. There we go. So we'll get that description from the user, and then this inventory at position this number of items. equal new item disk. Alright, so there we go. Else cout inventory full. Okay, there we go. And in case you noticed, I started using /n instead because it's a little more efficient than endline. Yeah, that could be a good habit to pick up. That's what I picked up recently, so I started doing that. Anywho, now we're adding some stuff to our inventory, and then we'll just say item added /n. There we go. You can just do the /n in here, but this shows it a little clearer. So there we go. There we go. Now all we need is a void menu, and it takes in a choice variable. So we'll have an int choice. Okay, then we'll have a truck. Alright, truck. And we will have a while choice is bigger than 0. Now we don't have to delete our inventory out here, right? Because our destructor for truck takes care of that. It takes care of all this stuff. So we do not have to worry about any delete stuff because we're already taking care of that. As soon as truck is destroyed at return 0, its destructor will be called, which in turn will destroy anything dynamic within truck. So you should be secure about that. And then we'll just do menu here. Menu, which takes choice, and truck. Okay, we're gonna have to do truck here. Truck, and a reference for that. Not constant because we're gonna have to change stuff in there. So truck, and then menu, choice, truck. Just like that. Just like that. Excuse me. There we go. So what menu does is it says menu. Okay, then we're gonna have a few choices. We're gonna have one, add item, two, get add item, print inventory. So we have add item and print inventory. Okay, that's it. Then we can have a string name for that, and then this name equals none. Alright, or we could have this string name equals none. This name equals name. So we can actually create a truck with a name. We can create a truck with a name, and then we'll have a function in truck which says string. I can show you two string here as well. This isn't the most efficient way to do this. Actually, you want to use string stream, which I'll come to later, but we can do it with two string here to convert wheel and stuff like that. So string get truck info. Alright, so it's going to return it as a string, and we're going to say constant, and we're going to do this, and we're going to say like this: return name, this name, whoops, new line that, oh whoops, never mind, like that, and then we're going to say wheels, oh whoops, one, wheel 1 equals, or left front, this wheel, this wheel f dot get size. We'll just do that. And then we'll just copy paste this, and we'll get a bunch of wheels here: left front, left rear, right rear, left front, Whoops. RR. So we got those. Wheels. Wheel 1. Oh, whoops. Slash N. Just like that. That's what we want. That is what we want. Just like that. So it's gonna give us all the info as a string. Okay, now this is the issue here. That the name is fine, but these are to string these. Alright. So what this will do is it will convert the integer to a string value. Now what is your problem? Print types of const char. Name. Whoops. Why? What am I doing, guys? Excuse me. What am I doing? Am I totally dumb, or just a little bit? I'm sorry about that. I thought it was some cout action going on here, but this is just. Whoops. It's an addition. We want to do addition here. Sorry about that. This should work. Okay, so we're gonna return all of this as a beautiful string. So this is get truck info. So we can do that. We can get truck info and get truck info. Okay, so get add items, print inventory, get truck info. So we have our 3 beautiful functions here without any issues. And we want your switch case for choice. Then case 1. There we go. Case 2, case 3, and a default. Just like that. Kablam. Hell yes. Okay, so now we want to add items. So we want to say truck dot add item, and it's going to need a string. So we need to have string temp item. Okay, we're gonna make sure the user get line sin.ignore. Always do sin.ignore before I get line. Sin temp item, just like that. Temp item. Okay. Wait, what? Add item. Oh, it takes care of it. Oh, never mind. It takes care of it itself. Look at that, beautiful. Actually, you don't want a lot of input-output in classes like that. You want to do it this way instead. But since we're making such a small example, I thought it wouldn't be a big deal. But no input-output in classes. Remember that, because everyone does not include. If another person is going to read your code, they usually don't have IOStream anyway. They don't like to include it in other programs. So never have a bunch of input-output stuff. Just do exceptions and stuff like that. So, anywho, that's fine. Then in all input-output will be in main. So that's much better. Okay, so this is truck dot print inventory. Truck dot get truck info. So yeah. Wrong input, bruh. Just like that. Voila. We have a beautiful program. Now it might crash. It did not crash. It did the wrong input brought at once. But that. Oh, okay. Oh. Okay. Yes, because I am totally dumb. Again, forgot the most important thing. Not sin, please. Choice. Yeah, I actually forgot that. See how choice. Just like that. So now it should work. Yes, now it worked. All right. So please. Let me just make sure to print an inventory. Did not crash. Get truck info. get truck info. Oh, wow. You actually, because it gives you a string, so you're gonna have to print that out. Wow. I'm so smart, guys. Get truck info. There we go. Name none, wheels, blah 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 blah. And you could give it a name down there if you wanted to. And let's see, let's add an item. Let's say le. And then get truck info, print inventory. Okay, it did not print that out. Let's see, let's quit this. Print get description. Alright. Inventory. New item description. Sin description. Let's see where we went wrong. Let's see where we went wrong. So item. String description. This description equals description. Wow. Well, I hope that was the last of our issues. Add item. And then print it. Yes, that worked. Okay, add item. Print inventory. Okay, so that's working. Get truck info and then add another item just to make fun, have some fun. Works. Alright, guys and girls, that's it. Sorry for the long video, sorry for all the mistakes, sorry for all that stuff, but I hope you learned something anyway. Classes and classes, arrays, all kinds of stuff, all kinds of fun stuff. And go ahead and play around with it, see what you can do. Thank you again, thanks for the support, and I'll see you in the next video. Bye-bye. Hey guys and girls, welcome back to another example video here on this beautiful channel on this beautiful day. What we're gonna do today is just talk about one thing that some people have been talking about in the comment section from the last video, and that is the member initialization list. And to be honest, I had kind of forgotten about it because it's a long time since I used that. Now it's really important to know about, so I thank those people for bringing it up. And I actually used pointers in the last video. And dynamic memory allocation instead of using this, which you could do because actually it's stupid to use pointers when it comes to wheels, since your car always has wheels, right? But still, you got to work with some more dynamic allocation, and they use the destructor right there. So in a way it's good because we are learning here, but yeah, to do it correctly you could do it like this. If you have a class wheel like this, you have your private section and your public section, just like that, and just copy this. And what we had last time was truck, and I'm not going to do the inventory thing because yeah, this is just to show how the initialization list works. So what we have is we have a size of the wheel, okay, and we're going to have a wheel int size 20, okay, just like that, and that actually our constructor right there, just like that. Now what you can do, instead of doing this size equals size, you can use the member initialization list up here. And what happens here is that, and this is important when it comes to inheritance later, you're going to be calling the constructors for your base classes like this. But anyway, what you do is you say size. You can't use this up here, sadly, but it knows, it recognizes which one is what. So wheel size, and this is that size. So there you go. That's it. That's all you have to do. Now, perfect. This will become 20. Alright, let me just think here. Now, what we had was, we had 4 wheels. Wheel LF. Let's just make the 4. Why not? LF, RF, RL. Wait, left R, there we go, and then run, just like that. Now, what we can do when we create our truck constructor here is that we use the same technique. Now, what I did was I had these as pointers, and then I said wheel LF equals new, right? Just to make sure I don't call the constructor 2 times and I don't make any copies. Like if I did like this and I said wheel LF equals wheel 26, like this, right? This creates an unnecessary object, which is then copied into this already created object. What the pointer would have done, what the pointer does in this case is that it just creates a new one and then puts it into wheel LF and it points to it. Now this is also unnecessary because then you have to go in and create a destructor and define it, just like the a nice person in the comment section said. You don't actually have to define this in that case. I still define my constructors always, so you have it there if you need it. But what this does is then you have to delete wheel down here. But screw that, right? We don't want to have to do that. So what you can do is just this is how you initiate your constants as well, I think. But anyhow, we'll talk about that later. So I'll say wheel LF 26, wheel RF 26. We'll just say 26 on all of these, just like that. 26, and then rear like this. 26. Now, oh, you don't have to do the semicolon here either. So there we go. Now when we create our truck, we just want to see out. Let's do a getter in here. Actually, here I don't have to define the destructor. Who cares, right? You know, you can choose either to do it or not. Get size const. There we go. There we go. Constant reference. Bam. Turn this size. There we go. Get size, just like that. Whoops. Okay, so we can do this for every single one, but we don't have to, right? I mean, I can do it for RF as well, because all of these, if one is, then the rest are as well. So we'll just make these two, and then we'll make a truck down here, and in the constructor we'll call the cout thingy. So yeah, 26, 26. So in this way you can initialize your variables to specific values in here, even if they're in the stack like this, not in the heap. So even if they're not dynamic, they're static, they're like this. And yeah, that is great. I'm really happy someone told me, because I had honestly kind of forgotten about that, which is dumb because it's a really important thing to know. But that's how it is with programming. Sometimes you forget things, and you gotta go check the references and stuff. Yeah. So, but yeah, thank you for watching and the support. Take care. I hope you learned something, and I'll see you in the next video. Bye bye. Hey guys and girls, welcome back to another beautiful video on this beautiful channel. Today we're going to just create a dynamic array using a class. So finally, here we are. Now this isn't going to be a pointer array, it's going to be a regular pointer array, which is the less efficient version. But let's start with this, and then we'll do the pointer one, then we'll do the template versions, and then we'll do all stuff. This stuff is very important because this can be coming on your tests, and this really shows your knowledge of pointers and classes. So stick with me here, and let's create a int array. This is dynamic array for integers. So class int array. I'm gonna speed through because I've explained a lot of stuff in the previous videos. So I'm assuming that you know a little bit about what's going on here. And this is a simpler version, so it shouldn't be too hard. Now we need a capacity, number of elements per usual, and then we need the actual array pointer. Just like that. Then we need the constructor, and this time we really need a destructor, excuse me. And since it's a simple array, we just have to delete the array. We don't have to go through every element. The pointer we have to go through every element. So, excuse me, I had to sneeze there. Cap 10 0 new int cap. Bam. We have our array. Finito. Let's see. So in private, we want the expand function, and we want the initialize function, just like that. And in public, we want the void add function, and we want a, what else do we want? We want void get at. Okay, we still haven't gone through the what do you call it, operator overloading, because we could use that in this, and I'll do that in the coming videos and show you operator overloading within a class. which will really help us, especially in this case where you want to use this operator within or for your class here. So, but for right now, let's just stick to this, and it should be fine. Now, what should we start with? Well, int from, actually, we can start with initialize. So that's just a simple for loop where we go from to cap, and we say array at position I equals 0, and then expand. Expand is the more complicated one, but for this one it's pretty easy. We double cap, we create a temp array with the new size, we copy over the stuff from the old one, equals array at position I, we delete the old array, we set the old array to the new one, and we initialize from number of elements, just like that. Now initialize should be above, just because it makes more sense, just like that. So it's a more base thingy, more basic function. Then expand, and then int, we have this finished, that finished. Now add, we can do get add. This is a exception throwing function. So let's say if index less than 0 or index is larger or equal to number of elements, we will throw out of bounds exception. Now there are other ways to throw a specific out of bounds exception, but for now this is nice. Now integer get at return array index, so we can actually get the thingy there. Yes, and then we can have a void pop back to pop the last element in the array. Now our if it's larger than 0, let's see, here we need the pre thingy, so it's gonna go down 1, and then it's going to actually put that to 0. Now we don't actually have to initialize it to 0, change the value, because it's gone, and then the next time we add something at that slot, we're still going to change the value. But still, this is going to decrease number of elements and do this. So it's going to decrease it first, and then it's going to do this, because remember, at the actual value number of elements, there is nothing. So we don't want to change that. We just want to go back one step, decrease it, and at that spot there is something, we'll make that 0. But we don't have to. This is not necessary. Is that how you spell it? What you can do is, in this function, just say like this. That's all you have to do in this function, in case number of elements is larger than 0. But I still did this just to clarify what's going on. So there you go. There you go. Else, cout array empty. Okay. Okay. And remember, no real input output for. Actually, we could just throw. This is not a good idea to throw here. Empty array. But you don't want any input output in a class. So I'll try to stick to that as much as I can now. And then add. Add is easy. If number of elements is larger or equal to cap, we'll expand. Okay. Then array at number of elements plus equals element. Now the reason for plus here is it's going to use the old value for number of elements first, and then it's gonna first do this, and then it's gonna add 1 to number of elements. Here the difference is that it uses the new value, the subtracted value, in the operation. So it's gonna take, if the number of elements is 10 here, it's gonna make it 9 first, and then it's going to do this. So it's gonna change the 9th position to a 0. And then it's gonna stay, number of elements is gonna stay 9. It's not gonna just subtract 1 for the operation, but it's going to actually permanently become 9 there until you change it back. So there we go. That's our integer array. So let's create an int array here. Int array. Whoops. Just call it r. Okay, r dot add. Let's say add a value 10, and then we'll say r. Oh, we can't do that yet. See, we have to learn about that first. Just like that. Let's see if this works. So I hope we don't get any crashes. We just need system pause. That's how it is. Pause. There we go. There we go. So 10. That's great. That's great. And then we can keep adding 11. Let's just do a few adds here. Just like this. More than 10, which makes it so. Okay. And then what we have to do here is we have to int get elements, and we will just return of elements, just like that. Just like that. Const. Okay. That seems great. Okay. What is wrong with you? Elements return. Excuse me? Okay, fine. Why not? Why not? We'll just leave it. So we could do this. For get number of elements, and then we will say I, just our usual index showing thingy, just like that. Just like that. And we have 21 elements. Bam, bam, bam. So it's a working dynamic array. Like a vector, kind of. This is more of a vector because we have pop back here. A real different type of dynamic array would have a remove function, which could remove something at any place in the array, and then copy over, just make everything else go one step back. And I'll show that later. I just have to make sure I am 100% sure of how I'm supposed to do that, and then I will show you that. But yeah, here you go, guys and girls. I hope you learned something. This is a good thing to know. This is really good to know because you learn about pointers and stuff. But thanks for watching. Thanks for the support. Take care, and I'll see you in the next video. Bye-bye. To another example video. This is our 50th example. Congratulations, we reached 50. Hell yes. Thanks for watching. Thanks for the support, and we'll keep going strong. But today, on this beautiful day, we're gonna create a pointer dynamic array class. So the same thing as we did last video, but for with a pointer instead. So let's just go ahead and do that. Let's make a class. Let's do them in int again. Int array. Okay. This time using a pointer. Public. So of course we need the private and the public. Let's go ahead and do our capacity. Whoops, int number of elements, and we need our pointer array, just like that. Int array. And our destructor. And for deleting a pointer array, what we're going to need to do is just what we have been doing before. We'll use number of elements through this. I won't use initialize, I think, or actually I will use initialize. You know what? I will, because that's my way. It's a more tedious way, but it's my way. So I will do that. Delete. Or wait, I actually did that in the previous video. You know what I could do? In this video I could use the condensed version, the easier version, to do this without initialize. And then one later I'll do the initialize. But I've already done it in a few videos back. But that wasn't in a class though, just so you know. So you can go watch that if you haven't already. So this should keep us safe. This should keep us safe. Cap equals 10. How did I do that? How did I go up instead of down? I don't even know. Okay, number of elements array equal new int. I always do that. Int cap. So we have all our stuff here. Everything is here. Now we don't have to initialize this, so we're fine. Would expand. So we don't need an initialize. Let's just do our expand function. So to expand this array, we're going to have to double cap. We're going to have to make a temporary array. Cap. And the pointer here, of course. See, it takes care of you. It tells you when you do something wrong. Then we have to copy stuff. So we'll use number of elements. So wait, array temp array I equals new int array position I. Just like that. That's how I like to do it. That is how I like to do it. To just copy and create a bunch of new things here, not to just straight up point to them. Which you could probably do as well. I just have to try that out later before I teach you something wrong. Then we have to delete the old array. So it has copied everything, yes. Elements. Delete array at position I, and then delete the actual array. And then say array equals temp array. Just like that. So these are all the steps to make sure that we have a expanded array. It should be fine now. I'm pretty sure that's fine. And then in public we'll have a void add element, and we'll have a get at as usual, and we'll have a add, get at, and pop back. So just like that. Just like that. Oh, this is how it was. Oh, I did the wrong thing in the previous video. It should be after the function header. You have to write const. So that's fine. And of course we need a, actually we can do it here. Get size, or size. Get size. Get size. There we go. And then const return number of elements. I know all about the const reference thingy, but you know what, we'll skip that, just because if you've seen my previous videos you should know that I use that mostly for bigger projects, but right now it's fine, it's no big deal. Let's see, so we have all this stuff. Expand, let's start with add. If number of elements is larger than the cap, then we'll expand, and then we will add something. So array at position number of elements, new integer element, and get at if index is less than 0 or index is larger or equal to number of elements. Throw bounds and line. Whoops, don't end the line. Exception. And then we'll return array index. And we will just dereference that, because we want to access the actual integer inside there, not the pointer's address. And then pop back is if number of elements is larger than 0. Here we'll actually just do number of elements minus minus. Or actually no, this is where it's important to delete because we want to free up space. Number of elements minus. Oh, what am I doing, dude? Delete. See, it's really early here, but I couldn't sleep because I have some issues with my lower back and it really hurts, so thought I'd make some videos to get over that. Delete array, number of elements, bam. So we're good. Get add, get size, enter, delete, expand. We're fine, guys and girls, we're fine. So let's make an int array dot add 10, and then dot get number, get size, get size, and then array get at I. There we go. I know I've been using endline again. It's an old habit, but this is better. So let's see if this works. Yes, it did. It did work. It did work fine. It worked fine. Let me see something from our previous examples here. We might just need to take this. It's our main. Oh, there we go. Sorry about that. I just have to remember to do this. If you add this, this is a memory leak check. So we'll see if we get any memory leaks. Nope, we didn't get any memory leaks. If you want to know what a memory leak looks like, I can show you that. If we remove this delete part here, we're gonna have a bunch of stuff in the memory, and it's gonna say here. This is what it says: dumping objects, normal block at something memory address, 4 bytes long, 40 bytes long, etc., etc. So as soon as you get that, you know that you messed up with a delete and a new somewhere. So that's fine. Now let's just add a bunch of 10s. Whoops. Just like that, to make it expand once. See if it expands properly. Yes, it did. Yes, it did. Now you want to print out the index as well, just like that, just to see what's going on. And we have 12, yes, so that means we expanded, and no memory leaks. So there you go, guys and girls, a pointer-pointer dynamic array within a class, or a pointer-pointer dynamic array class, rather. So I hope this helps you. I hope that you learned something. I hope that you can use this and keep practicing at this, and you'll be really efficient within no time. It's just that we need to use, what do you call it, the remove function as well, which is really important. But we'll get to that in a few videos. But thanks for watching again. Have a great day, and thank you for all the support, and I'll see you in the next video. Hey guys and girls, welcome back to another example video on a beautiful channel on this beautiful evening right here. So what we're going to do today is we're going to make a new file, and we're going to make a class in that file. Now to do this, what you're going to have to do is you're going to have to go into header files and create a, actually we can do this, since this is our, this is our, what do you call it, new class. This is our example project. You know, we have a bunch of CPP files and stuff. We can just create our class in another folder, so we have stuff right there. So we'll make a dynamic array today. So we'll make a dynamic pointer array, but we'll just call it the array, just like that. And we'll say virtual destructor, no base class, and just straight up create the D array right there. Now the CPP file for it comes down here. We'll just put it there as well, so we can reuse this later. Now we have our CPP file and our header file. So what I usually do is I take my header file and put it to the right, where I can easily access it, and my CPP file right here. And this is my main file in this case. Now what I'm going to do is I'm going to include this new class that I created, .h. This is how you include your own files. and that means that we can use everything in here. Pragma once is a thing that is called a preprocessor directive. Now this is different depending on which I just closed that down, which compiler you're using. So what you could do instead of just pragma once, all you needed in is the H file, the header file. Just so you know, don't do that in the CPP file. The header file is the one that gets included, and everything else is linked through this H file. But pragma once is for Visual Studio. So what you can do instead, if you don't have Visual Studio, is do this: if ndef dr. You can name this whatever you want. The name that I'm giving, the name that I'm giving, excuse me, as long as it's the same down here. But usually the standard is that you take the file name, you put it in capitals, and the dot becomes a underscore. And you just here you say. Now what this tells the computer or the compiler is that if this file is included multiple times, make sure we only define this once. If it's not defined, then define it and end the if statement. That's what this means. Now if we define it several times, there's going to be like two variables with the same name. There's going to be an issue. So that's why you use this. Now pragma once, like I said, you can use that if you want, or you can use this. Doesn't really matter. So go ahead and do that, and then we'll do, actually I like my private on the top here. So we have a class now in a separate file, and we have included in here. So we could make a darray right now, but it doesn't do anything obviously. So we're gonna have to fix that. We need a capacity, we need a number of elements, and we need a what will this be? This will be a container for, let's say, integers as usual. Or we could actually make sure that this is a include string. Oh my god, I can't type today. I'm sorry, it's late. String. Anyhow, what this does is, if it's included in here, by the way, I need to tell you this. If it's included in a H or header file like this, any library, you don't have to include it everywhere else. It will be included through this include, right? It will be like chained through that, so you don't have to include it everywhere. If I included IOStream in here, in the darray H file, we wouldn't have to include it up here in main. So just remember that. And it's good to do it this way. If you have a string included here as well, you should remove it if you include it in the header file for this this other class. So remember that, and we'll just make a string array, pointer of course, and then we'll just go ahead and do this. Now because we have a header file and a CPP file here, we don't have to define all our we don't have to define all our functions and all our stuff in the header file itself. We can do that up here. So that's a good thing. Now we need a void expand. We need a void init. Oh, initialize should be top. Not that it really matters, but I'm really anal like that. So we have this here. Now public, we're going to have a void add and then a string element, just like that. std again, sorry, and then we're going to have a std string get at, just like that, and then constant, and we will actually keep it like that. Yep, and of course int, we can make a const integer reference get number of elements, const, just like that. We can make this, I'll show you this as well. This is something called inline. I usually do this for my getters and setters. So inline, it just is a little more effective, at least from what I've learned. If you have smaller functions like this, you can just define them in here in the header file and just call it inline, because you're telling the computer that you're actually doing this. I think that's what it meant. I'm not really sure. You could Google that, but I just know it's a little more efficient for smaller functions. So it will just return this number of elements just like that. Now don't quote me on that, okay? But check that out. I'm sure you can find something on it. Let's see. So here we have our mem functions, and these are constructors and stuff. Okay, so we could, again, because we're pro now, we could use the initialization list here. Member initialization list. Cap is 10. Cap 10. We have number of 0 and array new string cap. I think you could do that, or maybe I don't remember really how to do that right now, so we'll just do it here. This array equal new string cap. Maybe I did it wrong. Let's try that out. Huh. Did that work? Oh, it worked. Okay, never mind. I just forgot. I'm sorry about that. Anywho, that's the member initialization list, so we don't really have to do anything in here itself. Here we have to do the delete action, so make a for loop of elements, and then this r dot I, just like that, and then we delete the whole thing. Again, if you haven't seen how to create these pointer arrays and arrays, or dynamic arrays, go ahead and watch my older, like maybe example 40 around there somewhere, videos, and you'll learn. It's really good to know. So okay, there we go. That's finished. Now we have our member functions. So let's do void and initialize. Now you have to do this if you have a separate CPP file, right? Now this just tells us that we're trying to define the initialize function, which is in this class. If we didn't, we will be trying to find, the computer tries to find an initialize function that, or it creates an initialize function, general function, not a member function for the class. So we have to specify that we're defining the member function here. Just like that. Int from, excuse me, we need an int from. Just like that. And then a for loop will go from to cap, and we'll just say this array. Actually, we don't really need the initialize for the versions we're actually making now, but we'll still put it in here. It's good to have. Then we have expand. Expand. And now the expand is the important part, right? So we have our steps. So cap, we double it. Then we create a temporary array. Temporary string pointer cap with the new size. Then we're going to copy stuff over with number of elements, and we're going to go temp equals new std string array position I dereferenced. So we'll copy that and create a new one. We have that, and then we're going to delete the old one. So all we have to do is actually delete up to number of elements, just like that, and then we'll delete the actual pointer array. I know this is kind of tedious because we've done this before, but this is like just for recap purposes, I guess you could call it. I'm sorry I'm a little tired today. My voice is probably a little low, but I'll do my best here. So then we deleted the old array, and the final step is to actually just point the old array's pointer to the temp array, to what the temp array is pointing to, the dynamic array. So there we go, and we don't have to initialize or anything. We'll just keep working with the number of elements here. So as long as we did that in here, yeah, okay, so we're fine. So we don't really have to use the initialize function actually. it doesn't really make sense in our case, but we still defined it here in case you want to do that other style of coding. Then let's see here, add and get at. That's what we need. Let's see. Add and get at. Okay. Just like that. And then to add something, it's really simple. If this number of elements larger or equal to this cap, we are going to expand. Otherwise, or no matter what, we'll add something. So this array at position this number of elements plus plus equals new std string element. Just like that. Bam! Bam, bam, bam. And then get at if int index. Okay, if index larger or equal to let's see, number of elements, or index is less than 0, we will throw out of bounds exception. Okay, and then we will return, let's see, this array at index, and of course we will do this. Bam. So we could do is a constant std string, or wait, you know what, we'll make a string reference because we want to be able to set it as well. No, this is get at, so we'll make it constant. Then we'll do set at for, nope, I changed my mind again. Let's just do this, because this means it's like for that operator to, you access it, you can either do something with it or not. It doesn't really matter. So yeah, we'll keep it like this. This is not really good. You want to overload that operator, which I will show you in a few videos here. But yeah, we're getting pretty deep into this, so I should show you that pretty soon now. But this is it. That is it. Now we have our dynamic array for strings. Now let's see, we created it here. Now we can say array dot add Bob. Okay, and then we'll make a for loop which goes to array dot get number of elements, and then we'll say array dot get at I, like that. We'll just see if this crashes or not. I hope not. Please don't. Okay, so print out Bob. Good job, good job. Now let's see if we can copy over the what do you call it, this memory leak check. So hopefully we don't have any memory leaks. Let's see. All you have to do is just close it and see, nope, no memory leaks, so we're fine. Now we'll add a bunch of Bobs, more than 10 Bobs, and just see if it expands. Yep, it expanded, everything's fine, no memory leaks. So that's how you make a dynamic pointer-pointer array in a separate file like this. And then you don't have to define everything in here. You have your separate CPP file where you define all your functions, and then you include your header file in here. You include your header file for the class in the CPP file for the class and the main file. So this CPP file knows what function prototypes there are and what header or what member functions there are, or member variables, sorry. And then you can define them here and include everything at once in here. Okay, so that's about it. Thanks for watching. It's been a while since I made a video, about a day. I had to travel a little bit, so, but yeah, thanks, take care, thanks for the support, and I'll see you in the next video. Bye bye. Hey guys and girls, welcome back to another example video here on this beautiful channel on this beautiful day. I'm back in my study town here, so I'm gonna have to speak a little low because we're living together in here. It's pretty early in the morning, but felt like making an example. So what we're gonna do today is something pretty important. As we've seen, we've used a dynamic array. Now I removed the old one since we used this one before. I removed the code so we can create it again, just to practice. Now the important thing is you can create a dynamic array with strings, integers, all kinds of stuff, and primitives and whatever, but you can also create these for your own classes, and that's really important. So I thought today we'd make a person class, and in that class we would use that class and create a dynamic array with that class. So let's say person, just like that. Bam. Okay, so we have a person class. Now I like to do this just like that. We have person. A person isn't going to be anything complex. Person is just going to be a container for a few smaller variables. So we're going to have to include string. Okay, excuse me 1 second here. There we go. Okay, so include string. So we're going to have name. We're going to have an integer age. And we're gonna stick with that. We're gonna stick with that. You know, you can add as much as you want here. And then we're gonna have getters for these and setters. So let's see. We're gonna have a std string get name const. Okay, and we're gonna have a return this name. Alright, now what we can do is inline, just like that, and what we're just copy this and create this age and say this int get age. So we have two getters here. We might not need setters just now. We don't need that. We just use our constructor here. So std string name equal none, int age equals 0. So we give it a default value. Okay, now we're not going to define these in here. We're gonna do that in here. So let's do. You don't want to give your default values in here as well. You just do that in the prototype. So you have that, and we're gonna actually use the what do you call it? The constructor initialization list here. So member initialization list, and it can in this list it can what do you call it? Differentiate between the local variables and the member variables. So you don't have to worry about that. So we have that done here. We won't need the destructor for this. We already defined the inline versions of our getters in here to return the age and the stuff. And what we can do is we can do this inline, or we can just do a std string get string. Okay, const and string, right? And what we'll do is we'll say person get string and then return. Now I'm going to use a function called toString. Alright, so we're going to do this name this whoops plus this. I think I used that in a previous video as well, but anyhow, age. Let's do this age this plus to string age, just like that. So we get a long string with we can call it toString. Actually, toString is a better name, just like that. And we use this toString and we get it as a long string. So our person class is finished. Now we're going to work on our dynamic array again. So person array. Okay, so why isn't that working? Well, we're going to have to include our new class that we created, person. So we included person. Now we can have a dynamic array of people. Now what that means is I'm actually gonna have to include the oh whoops, sorry about that, the array. So this means that we're gonna have a bunch of our own class in here. So we're gonna have to change some stuff. Person, it's not a part of the std namespace, so there we go. Remove that, and bunch of stuff. We are good. Person get at. Okay, well, it's a little strange. Anyhow, we'll work with that. It's the thought here that counts. So we'll start with this. This cap equal. Let's say we start at a 10. This number of elements equals 0. This array new person pointer cap. Okay, just like that. It's just like making a dynamic array of anything else. And then we're gonna have to do the delete. This array position I, and then we're going to just delete this array, and we're gonna create our member functions. So let's start with our private member functions, the initialize, and we actually we'll use it. Void the array initialize from, we'll use it, why not? So we're going from to cap. Alright, and then this array at position I equals a null pointer. And if you haven't seen my other videos where I go through in detail what's going on, this is just a few videos back, you can watch it. So this will be a little quicker so that we can focus on what's important. The array expand void, oh whoops, there we go. And then we will do our expand function here. Now remember the steps again. We'll start by increasing cap, doubling cap. You can do whatever you want here. You can add 2 to it, just don't add 1. Adding 1 is the most unnecessary operation you can do. So multiply by 2 is pretty good. You save a lot of space. And then you create a person temp array pointer, equals pointer, excuse me, equals new person pointer, the new cap, the new capacity, and we will copy over everything. This number of elements. Then we'll say this r.I temp array at position I equals new person, this array, and then we'll copy that value into that person. Now we need a copy. We should have a copy construct. No, never mind. It has one by default. Never mind. We'll talk about those later. Copy constructors and stuff like that. We're coming to that now, actually, in a little bit, and we're gonna overload the this operator, the bracket operator, as well, just in the coming videos here. Just after I show all these small details. So then we're going to copy that over. We're going to delete the old one. And delete this array at position I. Delete this array. There we go. Did I do that here? There we go. That's important. That's very important. So there we go. Then we're going to go temp array. We're going to assign the old one to the new one, and then we might as well this initialize from number of elements. We don't need this at all because we're using number of elements everywhere. Again, if you watch my old videos, you'll understand why we don't need it. Why are you crying? Okay, there we go. So we have all this done. Now we're going to have a void add add a person element. Okay. Now this is kind of meh because it has to create a temporary person. Now it's okay with integers and stuff, but when you have bigger classes, you don't want to pass by value like this all the time and have it copy stuff. Now in our case, it's fine because person isn't that big of a class or that big of an object. It just has a string and an integer. But otherwise you might want to either put in the parameters in here like a name and an int and then create a person in here, a new person at that position with those values, or you just pass it by reference, a constant reference or something like that. Now we can try doing this because, oh whoops, person, well actually it should, we could do this. Now passing in constants in here, you could do it, but it's not something I recommend. Let's just do a const person element. Let's try that. Let's see if that works without errors. Since I don't really 100% remember, but we'll see what happens. So if this number of elements is larger or equal to this cap, let's this expand, and then this array at position this number of elements plus equal new person element. We'll copy it over from there. So this new person here is actually created and stored. That's why it's okay to create it. Here we would have a copy first, and then it would copy into the actual person, and then this copy will be deleted. A bunch of unnecessary operations going on there. So we'll try to fix that, and then we'll say person get at d-array get at and index const. Okay, we'll do that, and then we'll say if index is less than 0 or index is larger or equal to this number of elements, we'll throw an out of bounds exception. Okay, just like that, or else if it doesn't, we'll return this array at position index. Okay, so we have get at finished, and then we'll say we have that inline right there. So we're basically finished with our dynamic array of people. So we'll try this. Let's say dir p array. Okay, and we'll say p array dot add person Bob. He is 25 years old, and we'll just say for p array dot get number of elements, we'll say pr dot get at I dot toString. Whoops. That line, and then we'll say cout, just like that, and we'll see if this works. Now we might get a bunch of crashing here. I hope not. Okay, that worked. So we got Bob, age 25. So we could pass it in by reference here. This is much better to do, no matter where it is. Even, I mean, you could pass in constants apparently, but it could be dangerous. It could be dangerous if you try to change it or something. We can test that out a little later. But let's then just add a bunch of Bobs here, 10 Bobs, and then we'll see if it expands properly. It expanded properly. We have a bunch of Bobs. We have a dynamic array of people, and it is using the toString function there to print them out. So that's it. It's very similar to the other examples we're making, but we're going steps at a time here. So I hope you learned something. Go ahead and work on this. We'll go into templates and other things really soon, and overloading the operators. So yeah, again, thank you. Thanks for the support. Take care, and I'll see you in the next video. Bye-bye. Hey guys and girls, welcome back to another beautiful example video here on this beautiful channel. We're going to be working with template again, and it's been a while. I made a template introduction video a little while back. Maybe you want to go check that out just before we do this. But today is the first time we're going to do template classes, because we were doing a bunch of classes and dynamic arrays and stuff up until now. Now we're just going to go ahead and make a fun little like a static array filled with dice. Let's just say that, because we just don't make stuff for nothing, right? So we're just gonna go do that. Let's make a, this is gonna like prove two things in one. So let's make a template type name t. This is how you do it. This is our magic here. T is going to be, T is anything. You can have anything in here as long as you just use this instead of another type, right? So this is our generic type. It's called a generic type, and this is going to be replaced later on. If you remember vector, this is how you make a vector int for something, and you can make another vector for strings, right? And this is where your t comes in, because it's going to be a generic type until you specify what type you want this array to be of, right? And you can use this in functions, and you can use this in classes. But we're gonna make a simple static array today with so we're just gonna call it sArray, private public. I'll quickly define what we need. We need a cap. We need a number of elements, and we need a array. So we use t here instead of anything else like integer or something like that, because we don't know what type we want the array to be of at start, right? At right now. So we're just gonna make it t. We're just gonna tell the compiler or the computer, like, bro, I don't really know what I want here. I'm really, you know, unsure about this. Let me just make it t for now. It's gonna be like, okay, let me just keep this here for you. And what we're gonna do is array, bam, and a pointer as well, because we're gonna make it static array, bam, not a pointer. What are we gonna need? We need a sArray constructor, a sArray destructor. We need a add function, void add. Here as well, since we're adding t values, we're not adding any specific value, we're gonna use t. So const t for the object, we're gonna be void, whoops, what do we need? We actually need a size. So int size const. This is going to get the size of the array, so return number of elements. And we're going to need a get at. So t get int index. Like that. There we go. I think that's all we need. So 5 functions. And one thing with these is, as you noticed, I'm not doing this in a separate file. I'm just doing it in here above main in the same file, because there is a thing with template classes. Since they aren't defined directly, you don't need a CPP file. What you need is only a header file. So you'll have to take your template class, and you'll have to define all the functions and everything in the same file, in the header file, and then you can just use that. So here is weird number 1. Okay, this is gonna be number 1 weird thing. What you need to do is you need to take this template type name t, and you need to copy it above every function that you're going to define. Okay? Every function. That's weird. Weird number 2. This is just stuff you have to memorize. This is just the way it is. Then you do sArray. Remember, we had this before. Now you just have to shove in a t in here for every function. So that's how it works, guys and girls. I'm sorry to say, but this is what you're going to have to do. And you just go ahead and define all these functions here. So this is great. I guess you can see the value of this, since you only have to write one array now for any type of element, instead of making a bunch of different person, like we did last time, person array, integer array, whatever. Here we just have one, and we can just use this for everything. So let's go ahead and create this. This cap equals, let's give it a default value 5, or int size equals 5. This is better. Whoops. Now, if you aren't really sure of what I'm doing here, what all this stuff is, I suggest you go ahead and watch my older videos. But this is just the maximum size for the array, and this is the current size of the array. So this is going to start at 0. This is going to become 5 here. So we have 5 spaces, and then we can add up to 5 elements, and this is going to be how many of those elements are valid elements, so to speak. Because it's empty from the beginning, but it has a maximum size of 5. Anyhow, this number of, why isn't this working? This, that's weird. This number of elements equals 0. This cap, I think it is because this, yes, this is why. See, I don't know why you're watching my videos, but for some reason you are, so thanks for that. But let's go ahead and let's just make this a new T this time, since we're using T, right? We don't know which one we want, but it will know by the time we create one. So this cap, that's why we're using T. T is a template value, generic type. And to delete, we just delete. Remember, we need these if we're deleting a whole array. This array. And then we're going to go ahead and here return this number of elements and add. We're going to say if this number of elements is less than this cap, we're going to add something. Add positions plus plus equals const object, please object. Now this as well might seem all confusing and stuff, but I'll try to explain this as good as I can. Object, there we go. Const object, sorry. Bam. So what this does is basically, in my previous videos I explained this as well, but I'll just tell you that this is a static array, so we're not going to be expanding this array. It's going to stop adding stuff as it hits 5 or whatever number you input here. But this is the current value. It's going to start at 0. So the first 0 is going to be, object is going to be added, and this is postfix, right? So this is going to add 1 to number of elements after object, after this whole operation is complete. So it's going to use 0 in here, add object, then do this, make this into a 1. So next time we add something, it's going to use the 1 in here, do the operation, and then add 1 to it. So we're going to get 2 later. So this is how we can just increase it until 5, right? Or whatever number cap is. And then, but else, since it's not dynamic, we're not going to expand this array. We're just going to write something. Array is full, sad face. And that line, bam. So we're good. And then here, if index, since we want to get something at an index, we don't want that index the user defines in here is less than 0, or it's greater than this number of elements, or equal to, actually. So if that is the case, then we'll throw an exception that says bad index. Or if it doesn't throw, actually just break out of this function, then we'll arrive at something called return, right? We'll return this array at position index, because then that index is valid. But the thing is that you can, instead of get, you can overload an operator to actually do this, use this with your array class. So what you would do is you would overload this operator here, and you could use these indexing operators for your class, array class. You can do that for this because this is a standard array, right? It's like array internally. But this is a class, so you have to actually define that operator in here for you to use that. Otherwise you have to make a specific function for it to get something at a position. I hope you understood that. I really do. But anywho, just trust me on that. So now our array is complete. We'll make a S array of an integers, and we'll call it MIA. Oh dang, yes, that's so cool. An S array for std string. We have we don't need std actually, so we included that. MSA, whoa. And there'll be 5 because I haven't defined anything. It has a default value. And to print out strings, you need to include a string to print them out with cout. So what we'll do is we'll make a for loop, and first what we'll do is we'll make, since it has the size of 5, we'll say MIA.add 10, MSA.add hello. Bam, that's a cool string. And then we'll copy this, and we will just say cout MIA.get at position I, end line. and we'll say MSA dot get. So what we're doing is we use the same class for two different types, because the type of this class, the T, is going to be defined and just chosen at the time of the creation of this array, right? So it's the same array, it just uses two different types, or handles two different types. So this is great for classes and stuff, because you can make one array and you can just use it for everything, just like vector. You don't need to make 20 different vectors for 20 different types. Make one vector class and then you can just use that. So let's go ahead and test this. I know it's gonna crash because it's my luck. Or if I'm pro. No, I'm not pro. Sorry. Sorry. I was so close to being pro. Just one little semicolon. Okay. 10 hello, 10 hello, 10 hello, 10 hello, 10 hello, guys and girls. I hope you learned something today with the template class. Just, yeah. It's fun. Has a bunch of uses, and I don't know, just have fun with it. Try it out. Test stuff out. And you can make functions with templates as well, like I did in my previous videos. Let's go and check that out. See how you can play with that. And yeah, go crazy, okay? This is a really big part of programming in C++. Well, not really big part, but still a pretty big part. It's pretty fun to use. And yeah, thanks for watching. Work hard, take it easy, take care. Have a great day or great evening, and I'll see you in the next video, okay? Bye-bye. Hey guys and girls, welcome back to another beautiful video on this beautiful channel. It's a beautiful day and it's a beautiful evening, wherever you are. I hope you're having a good time. Anyway, what we're going to be talking about is operators and overloading operators in classes. Now this is a really important thing. I kind of touched on that on my earlier example where we had this operator overloaded, the indexing operator. But I'm going to show you step by step a few things from start, right? So the next videos are going to be about operators and these important things that you need to think about when copying classes and you know, like the copy constructor, which we're going to be doing today. What happens if you don't have it versus having it, right? So let's make a class, an important class. Let's say class, what are we going to call it? Let's say dice, because we like dice, right? Dice. Now, dice is going to have a private variable and a public part. Dice has a constructor, like usual, right? Int number, int value, and then we have a destructor, just like that. Or actually, we'll define later. There we go. Sorry, I kind of lost my voice there. You're gonna have to bear with me into here. And what we're gonna have is int max value, because we're gonna toss this. And to have a dice, actually, do we need to toss the die? I don't think we need to toss the die. I just think we need to make sure that it has a pointer in it. Now, this isn't gonna make any sense, but let's just go ahead and make max value a pointer. For some reason we wanted to make it a pointer, okay? So what we're gonna have to do is we're gonna do dice. When we define this int value, we're gonna have to make max value a new int with the value. With the value basically. But what this does is, this is completely unnecessary. But what we did was we made a pointer to an integer and we dynamically allocated new memory for max value as a new integer. Okay? But this is going to help us show deep copying versus shallow copying. I'm just going to type that here. Shallow copy and deep copy. Bro. And the difference between these two is really important, especially when you have dynamic arrays and stuff. So here we go. We have a pointer basically in the class, and something is dynamically allocated. So dice, let's make the destructor, just like that, and we'll say delete max value, just like that. This doesn't really matter. I like using this always. Because it helps me keep track of stuff that is part of the class. So here we go. We have a destructor and a constructor. Now what happens now? Let's make a dice with the value 10. Okay. Now let's say system pause. And whoops, system pause. And st or cout dice d1. And let's say d1. We need a get value function. Void get value const. Let's just go ahead and return this max value. Just like that. The reason I dereference this is that it's a pointer, but you return, whoops, sorry about that, int. I am totally beat. I am completely beat, tired, and done. Completely done, bro. Stupid symbols. Okay, here we go. And we're just gonna print this out. Get value. And that line. Whew. Okay. Let's see what happens. We should get a 10. We should get a 10. We got a 10. Okay? Now, the thing with, whoops, the thing with deep copying versus shallow copying is that when you have a regular integer, okay, you have a regular integer, what happens is that in memory, this is going to, let's say the stack versus the heap. We have our 10 here, we have our dice with the value 10, and we're gonna create a dice d2 equals d1. So what happens here is that we're creating a new dice using another dice, right? And what happens is that the 10 here is going to, if this was a regular integer, it would be totally in the copy constructor. The default copy constructor, it's called, does exist here. We don't specify it, but C++ has its own, right? So it's going to basically do this. It's going to go through dice, and it's going to take all the memory variables and simply use this operator and just you know, assignment operator, and just assign value A to value B, right? It's just gonna shove stuff over. It's not gonna do anything special. But with pointers, the problem is that if we had a regular integer, the 10 in the stack would become a 10 in the other integer, the one we're copying to, right? The max value in here would be 10, because you can do that. You can do int A equals int B. But with a pointer, what that does is that pointer is going to get the value from dice 2's pointer is going to get to be pointing to dice 1's max value. And what happens then? Well, you get all kinds of errors. You get like, you know, it's not two different variables. It's pointing to the same variable. That's a big issue, especially when you delete something, because if dice 1 is deleted, dice 2 isn't pointing to a max value anymore. It's not pointing to anything. And when you try to delete that, it's going to crash. You're going to crash because it's pointing to a nonsense value, right? So you need to remember that. And in that case, you need to tell C++, hey, look, just stop here. Use my copy constructor, because I have a pointer in here. I need to do something special. I need to make a special case for this to work. Okay? So how do you do that? Well, you just go ahead and do this. Dice. Okay, dice. And then you just do this. And then you do a const object. You can call this whatever you want, but I usually call it object. And it is just a constructor, just like this one, but it takes a dice object, another dice object. And what it does is, what we're going to do is we're going to define this here. And make sure that this pointer isn't just assigned, like this isn't happening. This max value equals object dot max value, right? This is not supposed to happen. This is going to be pointing to object's max value. We don't want that. What we want to do is new int object max value and dereference that. Bam! So we're copying. We're making a new integer in max value, and we're copying, because remember, this is only called once. Only called once when a dice is created. Copy constructor isn't called again, ever. So this is going to be called instead of the regular constructor. Okay, so we're going to have to do everything we do in the regular one, just with a special case with another object in play here. And we can access objects max value even if it's private, because we're in the same class and we're in the constructor. So we don't have a problem here. So what this is going to do is it's going to create a new memory location and make a new integer with the copied value from the other object. So remember that there's a big difference between giving one pointer the address to the other pointer instead of copying the value, the data, and putting it in a new memory location. So here we go. So what this is going to do is we're gonna just print out D2, print this out. Wait, what we have to do is do this. Bam. It's like that. Wait, what happened? D1 identifier not found. Wait, I did something wrong here. D1, D10. Undeclared identifier. Oh, I must be missing something here. This object, return max value. I mean, it should be fine. Oh, whoops. What am I doing? Okay. That's kind of dumb. But, let's see. So, 1010. Okay? 1010. And no errors with the delete. Now, I think this should work since it's the same thing. I mean, the assignment operator is going to be used as the copy constructor. Like, it's going to be called anyway. Now, if we did this now, D2 equals D1, this is a totally different thing because dice has been created already. Okay, it's been declared, it's been created, so copy constructor can't be called again. The assignment operator is going to be called. Now, in this case, that's a problem as well. We need to create a assignment operator as well for this special case with pointers. Okay, so anytime you have a pointer in a class, you need to define a copy constructor that handles this special case and a assignment operator. Now, well, I'm going to do that in the next video so we don't have too much to swallow in one time. But just remember, this is only called once instead of the regular constructor. Now, I just want to see if this works, if my theory is correct, and I remove this, then we should get 10 in both, but we're going to get a crash. Yep, we got a crash. Okay? That's because it tried to delete something that wasn't, it was a nonsense, it was rubbish. So what we could do is do another thing for the assignment operator, is that we make a dice with 12, okay? Now we try to assign D2 equals D1. Now it's going to start pointing to that. Let's see if that works and crashes as well. Yep, it did that, but it's pointing to the same space in memory. It's not two different variables, it's the same variable, and that's going to give us crash. So there you go, that's it. Remember this and work hard and make sure you handle these special cases with the pointers. So yeah, thanks for watching, take care, have a great evening and all that stuff, and I'll see you in the next video. Bye bye.